I think that's most folk in the door now. There'll be a few more that will appear as we go. I'd just like to welcome you all along to tonight's webinar. So tonight we're going to be looking at 3 pieces of technology as part of the One Agritech project, which has been running up here in the northeast for the last couple of years now. The technologies we're going to speak about tonight has been identified as potential solutions for challenges that we're finding on farms in the northeast. They were picked by the project management group for this project, which is made up of local farmers, and it's all things that are pinch points within their businesses, or they could see there being a technical sort of solution to what they were trying to do. So the challenges that they selected, that they thought about and they picked, was looking at monitoring of crops and how that can lead on to making more informed decisions on farm as you're going through the season. Looking at the tracking of machinery and fuel and trying to maximize efficiency through that, and also looking at soil and plant nutrition through the season and trying to look at that in real time so that we can change our plans and change our nutritional plans as the season goes on. So the plan is to look at these 3 pieces of technology, to trial them on the management group's farms this season, and then come back later in the year to assess how they have got on with these pieces of technology. So the speakers that we've got this evening, first up is Edwin Nichols from Droneag and Skippy Scout, and we've also Clive Blacker from Exatrec, who is going to speak about the Exatrec product, and I'm going to do a little bit just on the Stenon Farm Lab, which is a in-field testing. So Edwin, if you would like to share screen, we will just kick off from there. The chat is open at the bottom. If anybody's got any questions, please put them in the chat, and we will try and we will pick through them as we go through the presentations. Or we'll, at the end of each presentation, we'll pick up on any questions that there is. So please put them in the chat or the Q&A below, and we'll be able to answer them at the end of each presentation. So Edwin, I'll just pass across to you.
Cool. So I'm just hoping you can all see my presentation here before we start. Cool. But hi guys, I'm Edwin. I am head of sales for Droneag. Some of you might have heard of us. We're actually from Northumberland, so not too far from where you guys are based anyways. But essentially what we've got is a solution for quick crop walking, essentially, which is our product called Skippy Scout. Right, so essentially Skippy Scout is our software solution. How the company started in 2015, our CEO Jack came back to the family farm, having worked in the drone industry, mainly around filming and photography, and did a lot of work for the BBC in his early days, but essentially moved back to the family farm. And then him and his brother Hugh came up with the idea of using drone technology to help with farm decisions, essentially. And what we originally started doing was teaching people on essentially how to use their own drones on their farms, but using other people's software. So we used to use things like Drone Deploy, Pix4D, various other mapping softwares out there as well. And what we found from that is essentially it wasn't quite fit perfectly for farming. They were almost like construction software packages, which were then edited to fit the farming landscape where it wasn't really built to suit. So we found a lot of issues with that software. So in turn, we came to actually build our own and solve those issues in the process that we were finding with other software platforms. So essentially what we do is we take off-the-shelf DJI drones. So for example, one of our most used drones is the DJI Air 2S. That drone goes for about £550 expat. So you're really not talking a huge amount of money in terms of regular farm machinery. And then what we've done is created a fully automated platform that then essentially does all of the jobs, from actually flying, taking the imagery, downloading the imagery, and analyzing it, and then sending it back to you in an easy to read format. But essentially how it works, so essentially, well, a lot of people can actually get flying within the first few minutes of having the app. So we've made it as easy to use as possible, just so that, that was one of the hurdles that we were finding with all of these other technologies we were training on. They were quite complex, and some of us that have been working in tech for quite a long time, we were even struggling to use them. So we thought, how are we going to pass this across to people that haven't used drones before, or might just be getting into drone tech? It just doesn't really fit into it. So we created our technology to be as easy to use as possible. But all you have to do is buy an off-the-shelf drone, add fields and point of interest. That's where the drone will actually go and visit around the field. And then we've got two different levels of capturing. So we've got what we call our scout spheres. These are our 360 overviews of the field. So it's like looking at your field from a top-down perspective. And then we've got our actual scout points, which are the close-up images, which are taken about 2 meters high off of the crop. And then essentially, you get a report on crop health, problems that might be in the fields, and they're generated within minutes of you finishing the flight. And then you can visit the same points repeatedly over the season to monitor trends. So this is just an example of what we produce for one of our main crops that it's used for worldwide, which is oilseed rape. So our AI will produce various analytics, including plant counts for emergence, insect damage, crop cover percentage, weed cover percentage, unhealthy crop, which can include, yellow, purpling leaves, true green area index. This is essentially where we take the weeds out of the equation and give people a crop only green area index value to help with nitrogen application. We do a crop variance percentage, and this can give you an idea on whether or not you actually have to do variable rate nitrogen, or whether it's fairly safe bet just to do just a flat rate. And then we have flowering fractions, which can give you an idea of how much your field's going through flowering and when's best to apply fungicides. And then we've got a growth stage predictor as well. And then after that, it goes into pod fill, ripening, and then senescence through to harvest. So for oilseed rape, we have that full analysis suite from emergence all the way through to harvest. And now essentially, we're planning to expand that throughout more different markets and across more crop types. So this is the scout spheres that I was mentioning earlier. So it's a full field overview. Essentially what you used to have to do, it would be called creating an orthomosaic, where essentially a drone would have to take 300 to 600 images across a field. You'd then have to stitch them all into one big map, and then you could make analysis on it, and it would be like exactly the same as what you're seeing on the screen now. What we do is we actually take 28 images, and then we stitch them into a 360 image, which you can then manipulate around to look at your farm from 100 meters above the field. And this is all done automatically through the system. We've also got some case studies, and if anyone is interested in looking closer at these, you can let us know, and I'm happy to send them out. But they're also available via our website. But essentially, we've been working very closely with Agri in the past year. They've got more and more agronomists using our system now to help them with various analysis on farm as well. So for nitrogen in cereals, we've seen savings of over £43 per hectare, using our average green area index values to recommend nitrogen rates. And for nitrogen for OSR, we've been seeing savings of over £60 per hectare, again using the average green area index to recommend flat rate nitrogen. And then we've also this year started doing some targeted herbicide application, and we've seen savings of up to £44 per hectare, using our scout spheres and scout points to target blackgrass in areas of establishing oilseed rape. So we're now starting to essentially put together these case studies and show people not just that we can capture data, but then how you can actually use that data to then benefit you on farm. And we have agronomists that use this and use it with their clients. We have farmers that use it and send the information to their agronomists. So we really don't mind essentially what job role you have. We work with all different types of people. We even have some people which aren't anything to do with agriculture, and they just provide the imagery as a service. So we have quite a broad range of customers. This is a little bit of information on our pricing structure. So essentially for tier one, I'm not sure why the pricing's disappeared off that. I don't know. But either way, tier one, the first month is free, and then it's a 100-hectare limit with one user. That's actually £50 a month, or we do it for £500 a year. And that's, you know, for your small farmers, but also people that are maybe wanting to trial it over a part of the farm for the first year or for the first few months, and then before then scaling it up. So we're very flexible with our software packages. Tier two is £1,000 a year for 1,000 hectares, so it works out £1 per hectare. You've got 2 user limits, so you can have multiple people on the farm flying if you've got more than one drone. Tier 3 is our enterprise package, so for farms over 1,000 hectares, and we charge £1.50 per hectare per year. But essentially, this comes with dedicated support, various different options around dashboarding and looking at your data in slightly different ways. And then we have our Tier 4 enterprise, and that's for more agronomy firms, and they pay, you know, a per user ship and then a per hectare fee as well for the service-based platform. But then they come with unlimited area and much stronger support label and white label options for adding, you know, various branding to reports and stuff like that. So market traction. So this was as of August last year. So we've changed a little bit since then, but we're currently in 19 different countries, and we have been flown on 1,181 farms in that last year. And then in the last, end of start of the new season, we'd had 54,000 images added for that season. And all of those images are then used to help retrain various AI algorithms as we move forwards. Essentially, not only are you gathering this data to benefit yourselves on the farm, but you'll also be benefiting the system for you to use at a later stage as well. So it's a very good sort of project to be a part of. But then at that point in time in August, we'd had 412 flights in the last 30 days. So we're really starting to get quite high userships now, especially it's growing quite rapidly in the United States and Canada. Obviously, the bigger the fields, the better the system works, essentially. You know, the more time that's saved, and that's what everyone's about, essentially, is saving time, but also creating that actionable data that you can then use season after season. So Skippy Scout mapping. So we have our own prescription maps, and this can be for spraying or spreading. And that's where we use the Skippy heat maps, which are obviously created from the Scout spheres. And then we also bolster that with the data that we get through our reports. And they provide a variety of crop specific metrics, which we can then use for various applications. And we can also produce a wide range of heat maps, you know, like vary crop cover establishment, flowering ratios, ripening, pod fill, or senescence. So essentially, if you need to do some sort of accurate spray, we will probably be able to gather some sort of data to help you do that. And then we've also got Skippy sphere zones. So this is essentially a quick and accurate way of zoning parts of the field. And this could be for anything like doing targeted application of weeds, similar to like the blackgrass case study that we've done, or maybe you're planning to reseed this part of the field because it hasn't quite established as well as you were hoping. And that can really be quite a benefit on farm. And essentially, this is kind of what we're going into / working on at this current point in time. So obviously Skippy Scout is our fully released product already, so it's out there being used around the world. We're now working on a number of other different products as well. One of them is actually using base station systems. So obviously Skippy Scout is more built for broad scale arable agriculture, so large fields, where what we're producing now is actually a trial plots version of the app, which is for, you know, agrochemical companies. and that's mainly based around the sort of 2 by 10 meter trial plots, where instead of having someone fly it there, we'd actually have base stations positioned around the field, and they would do automated flights as and when needed to collect data throughout the season for them to then analyze when it starts getting towards harvest. So that can be quite useful for, obviously, we're all about time saving, like I said earlier. The base station put up to a 99% time savings because no one even has to be there when it flies. And we're working on these beyond visual line of sight applications now for the CAA, and essentially working towards quite a positive future where automation is becoming quite apparent. But essentially, what we're also then working on is drone sprayers. So you've probably heard a bit about it. Scotland being one of the largest, well, potential users for drone sprayers, especially for bracken spraying, but also for other application as well. But what we're quite interested in, we've been sort of one of the very early dealerships for DJI drone sprayers for years now. And now we're really starting to push legislation. So we're hoping to do some trials this year around slug pelleting, spraying glyphosate and stuff like that. And then the general idea is that we're then working with the HSC and the CAA to then push forwards more legislation and get, you know, people actually using drones on farm. But you know, these all kind of link in together because the idea is that we then want to build prescription maps and stuff like that, which can then be exported into the drone sprayers. And then, you know, in seasons like we've had this year, where we've had god awful weather and we can't actually get out onto the field, you know, if you need to apply a last minute fungicide, hopefully soon we'll have drone sprayers there ready to apply it. But that is the last slide from me in terms of telling you what we do. But obviously, if you've got any questions, I guess now's a good time, David. I'm not sure if you've had any or not.
Yeah, if there's any more questions, just pop them in the Q&A. I've got one just about the scouting points that you've got. Is that is that something that you create yourself, or is that something that is sort of produced by the package itself as to where to go and have a look?
Yeah, so at the moment it's produced by the user, and you can produce them in a number of different ways, either by, you know, creating an average across the field and just tapping, you know, in randomized locations, or what you can actually do now is use the sphere image, so the 100-meter high full field overview, and then you can actually, off of that interface, pick the scout points that where you'd like the drone to go and visit off of that interface, so you can actually look for the patches of variance based off of the high up overview. But the
Okay,
general idea is down the line, we might switch that out and then use some sort of AI model to actually then pick the scout points. So you do a full field overview to start with. It will then look at the field in general, pick out points of variance, and then put a couple of points in good areas, bad areas, and other areas that might be, you know, average throughout the field, and get a good sort of sample collection. So, but at the moment, it's all done by user.
so I suppose that's in that way, it gives a bit of flexibility that if you know there's a good bit of a field or a poor bit for another reason rather than just the crop looking poor, then you can select and do it that way.
Yeah,
Yeah.
absolutely. And we have quite a lot of users which will pick points based off of soil maps, or they might pick them based off of seeding maps or yield maps, or maybe even drainage maps. Especially this year, a lot has been done around drainage maps and maybe looking at patches where drainage is not particularly good, and then hopefully changing that when we get some dry weather. But we've seen some incredible maps throughout the UK where farmers are suddenly starting to see where they've got drainage which they never knew about. And, you know, that's where they've taken a sphere 100 meters high above a field, and they've got all of these weird lines all going in different directions. And for one of our customers, we found out that he used to have, well, he had a field which was split into 4 different fields. He obviously turned that into one bigger field, and then he obviously had a lot of drainage channels all running in different directions. And it turned out it was obviously flooding the center of the field. and it was because of a load of drainage that he never knew about from before he actually took the farm on. So it's not only about monitoring crops, but also helping to analyze just general farm stuff throughout the year.
Yeah. And I take it the software can be on your smartphone or something, so that you can take a point and go back to where it is in field as to
Yeah.
where you've seen it. Right.
Yeah, exactly that. Yeah, so it works on both Android and iOS phones. We also work on some drones which have a screen inbuilt into the controller, so you can keep it completely separate from your phone. But essentially, yeah, as long as you've got a GPS signal, you can be able to find the same points through the app. It will show you your location, obviously the point location. So if you see anything where you think you might actually want to go and have a closer look, you can actually walk to those points as well.
Yeah. Okay, we've got a couple of questions from the
Mhm.
folk on the webinar. So the first one is around, can Skippy Scout produce variable rate fertilizer plans? Edwin only mentioned flat rate nitrogen application.
Yes, so we can produce variable rate nitrogen plans. We just find that not many of our customers really do variable rate now. We actually had more people doing variable rate a couple of years ago, and now they seem to have moved back into flat rate. So I think it really depends on on people's machinery, but I think with the SFI stuff which is coming out this year, I think we'll see an increase in variable rate again. So, but yes, essentially we can.
Good, perfect. The next one is drone spraying. How far off is that from being commercially available? How much can a drone spray in a day?
Yeah, so essentially, I mean, I'd love to say very shortly. Unfortunately, we're dealing with the HSE and the CRD, so it's never an easy situation. We've sort of been saying, "Oh, next year" for the last 5 years, but now we're actually seeing some movement in terms of they're quite interested in doing trials with us in terms of using regulated chemicals. So I'd like to say that this year we'll set out this year to do trials, drift studies, stuff like that, and then hopefully be available more into broad scale agriculture next year. But how much can a drone spray in a day? Really does depend on the models. So we've got 3 models, or 3 or 4 models now in the UK for DGI anyway. The smallest having a 10-litre tank, and the biggest now going up to a 40-litre tank. And the biggest can do about 16 hectares an hour. So you can really start to get quite a lot of coverage. But also what we can't do yet, but hopefully we'll be able to in the future, is also use swarm technology, where you're using multiple drones at the same time, all running off the same controller, and that's where you'll really start to cover quite a lot of ground.
Perfect. No, spot on. A couple other ones. Is the software compatible with other DJI models? Magic 3 series.
Yes, so the software is compatible with other DJI models. Our most used models are the Air 2 and the Air 2S, and we're very nearly compatible with the Mini 3 Pro, and also the Mavic 3 Enterprise and the Mavic 3 Multispectral as well. So those are our sort of 5 or 6 models that we tend to point people towards.
Good. Yeah. And some more things coming along, which is always good to see. And the last question was, how effective is the software? I think this is based on this year's crops. How effective is the software for plant counts and cereal crops?
Yeah, so plant counts and cereals crops is probably the more difficult style of AI that we tend to do. It's accurate to about 10% crop cover, and then as soon as you get tillers start crossing each other and leaves start crossing each other, that's when the accuracy kind of goes out the window. So we're accurate up until about 10%, and then we tend to remove that out of reports, and then we just go on to crop cover, green area index, and then crop uniformity. But all of our AI models will be improving a lot over the coming year. We've got in-house AI engineers now, so and with the increase in imagery that we're gathering, it only gets better essentially.
Good. No, it sounds Yeah, it's just it's a kind of build it and they will come a little thing, but isn't it?
Yeah.
It needs more imagery to make the thing
That's the thing, yeah. It's just kind of a chicken and egg scenario where obviously we want to be able to make it, but we kind of have to have people use what we've got now to improve it. So
Yeah. So no, perfect. Thank you very much for that, Edwin. I hope folk found that interesting. There's certainly a few things coming along that looks interesting there, and like I say, we're going to trial it on one farm this year, looking at spring barley, winter oats, and winter wheat, to try and follow those crops through the season and see what it tells us. So we're going to do that this season and see how we go. So be interesting to see how that works. So thank you very much, Edwin. And so if you could just mute yourself, Edwin, we'll just go across to Clive. So our second speaker is Clive Blacker for Exatrec, and he's going to speak about some of the innovation that there is with Exatrec and how it can be used on farm.
Brilliant. Well, lovely to meet you all. Just to give you all a little bit of a background to me and what I do. So I'm based down in the Vale of York. I come from a family farm, but I also have a precision ag business and help farmers adopt and use technology in different ways. And one of the challenges that we all have is definitely around data capture and doing that accurately. And certainly on our farm at home, we've had lots of challenges with that, with the contracting business and trying to be able to make sure we're doing the job properly, getting the right data, accounting for what we're using machines for properly. So I looked around for a long time for different solutions and did have a go at building my own systems for tracking and telemetry. And then came across Exatrec, and they're their company that allowing us to then look at utilising or developing their technology into any brand of machine that allows us to capture that machine data automatically. Oh, and this is where it all goes wrong. I think I'm having the same problem that Edwin had. There we go. So what are the challenges we've got then? So, here we go. So the challenges. So data today is becoming more problematic in that we're needing different sorts of data than what we've typically captured in the past from a traceability and accountability perspective on farms. Some of that's coming from the perspective of what we might need for compliance. And as that gets ever more onerous, tracking and proving what you've done is becoming quite important. But equally, carbon is becoming more important, and people are starting to think about that. So when we're starting to think about carbon, then greenhouse gas emissions are really important. That means that we've got to understand how and where we apply our fertilizers, but equally there's fuel use. The other challenge we've got is that there's lots of different systems out there with technology and data, and you know we have this vision of a data insight connected future, and having all the data coming into one place, which is often challenging, and finding systems that talk together is often a real problem. So when we start thinking about the challenge with climate change, with fuel and fertilizer, and where we might want to go with soils and soil health in the future, having the right data that can be captured, that can supply multiple different data requests or data challenges is really important. And historically, I'd have had lots of data around my compliance about what fertilizer I might have spread, how much I put on a field, but I would have never tracked how much fuel I might have used on that operation or where that may have gone, or actually thought about accounting for the other fuel use in between those operations. So having a system that I could automate that data capture and give me that ability to do that was something that I thought was a bit of a holy grail. So I started working with Exatrec, and they're a startup company in Germany, and they're one of their leading sort of farm innovators that have spent a lot of time from a digital perspective and an engineering perspective building and developing a hardware and software solution that allows us to really capture data on any machine and any type of machine. Essentially, what it allows us to do is give us precise machines oversight, so we can monitor our whole fleet. So it doesn't matter whether you've got a combine or whether you've got a tractor or even a quad bike, we can fit technology to those systems and track where they are. It allows that to sort of meet the fleet monitoring of those systems. Now, while it can help with farm security, this shouldn't be used as a security system. It doesn't have any of the sort of systems you might want for an immobilizer or other things in that sense at this stage. So don't confuse it with those sort of systems. It's more about getting the data. And essentially what it does is it allows the automatic data capture so that all the data you want from the farm and the operation is done autonomously. Depending how much you want to invest in the system will allow you to really capture every aspect of what the machine and operators are doing on farm in simple ways, autonomously with machines or through apps, and allow visibility in new ways as well. And it really does help overcome some of that paper chaos that we have with lots of different systems and trying to manage them and bring them together, which hopefully will help us be more resource efficient. So the sort of the systems we can introduce, there's the fleet management, so it's independent of manufacturers. We can put it on any machine. Automatically captures the activity based on what the operator's doing and the implement that may be behind it, because we can set all that up in the settings. It really does automate the documentation, and it gives me improved efficiency readings in terms of what I can achieve then with accountability for carbon, for example, or fuel use on fields. Essentially what the system has is a number of different aspects. So we've got the ability to track all our machines. We can allocate our costs to those. So if we wanted to do things for different specific customers or partners, if we're contractors or different enterprises, we can log and record all of that information together. It works on a web app across the internet on any web server. And there are a number of different phone apps that are currently available and in development that will allow us the ability to actually see what's going on in your fields, out and about on the go, and allow us to capture other bits of data as we do that. And some users are saying it's improved their fuel usage and performance by up to 20%. So there's clear benefits that you can see by taking that data or capturing that data. Essentially what the system does is that it automatically captures the data. So there's no driver intervention needed. There's nothing a farmer or operator needs to do. It just automatically logs the machine data for the operation and records that and presents that in different ways. There isn't any buttons to press, so we can't even get it wrong by not turning it on or turning it off or making any operator errors on that. And essentially, when we define our machines, we can link an implement to the machine, and the machine will automatically pick those up, and then it will categorize them into different categories. And you can see there's a daily activity dashboard that you can see here where somebody's been spraying and fertilizer spreading, they've been doing some carting, and they're doing some forage harvesting. All the data is captured autonomously on the machine, so it gets data for very regularly off the CAN bus, and it uploads that, and you can see there's a breakdown in the bottom there, in the bottom right of the picture. You can actually see in that particular case, I think it's the fuel use across that operation where that guy's been, and it's split the job into different categories. So you can see the blue areas on there where it's turning, the green areas are where, for example, it's operating in the field, and the yellow is where it's on the road. So you've got the ability to really understand the whole performance of that machine operation. What it also allows us to do with the latest upgrades is get rid of some of the other hassles and challenges that we have. It removes the need for file transfer, so it emulates a USB memory stick. We can plug it into the side of existing rate controllers, and we can then send Isobus job files directly from the farm office straight to the machine without the need of the implement or USB memory sticks that we've had in the past. And that's a new feature that's been available since November this year, and we're just testing that at the minute, or we would like to if we could travel on the fields. We can certainly get the data to the machines, but the machines can't travel at the minute, which has been a bit of a pain in the proverbial. But as somebody kindly said to me the other day, we're all in the same boat, which I thought was a very apt phrase to suggest this year with all the water we'd had. Not that this will track boats, I don't think. I've not asked that question. So the automatic file transfer, that I'm really excited about that development, because that has often been a challenge and a limitation to precision ag systems in getting data backwards and forwards from machines. The data, once it's all plugged in, it all automatically records the as applied data. So there's 3 or 4 different components that I'll go through that are installed on the machine when we set them up. And essentially the tracker will measure both the engine CAN bus data and also Isobus CAN data. So any of the data that's floating around on the machine as it's operating is all captured and recorded within the background of the system. So we get fully automated data recording for what we've achieved in the field with all our applications. It allows the ability then, if you're running multiple fleets or different types of vehicles, to compare the field performance. And for example, one of the users, the first year he had it here in the UK, we found that he had a green branded Agco tractor, I should say. I won't name the names, but that was performing 30% more fuel efficient than the red branded Agco tractor that he had. It was achieved in an extra 30% output, and the fuel use was improved on it as well. So not only was it achieving more with that tractor, it also was more fuel efficient in the process. And it was just quite interesting being able to see the same machine on the back, or with data that's autonomously captured, the same blade and drill on the back of both tractors, how the performance of different tractors on the front of that drill could actually be measured and analysed between them. And we had no idea, it was just something that was it was just something that came out the data that we hadn't expected. I suppose we should know about that, but and this example here is where they've done some trials out in Germany looking at the statistics of CO2, carbon release and fuel consumption. And that's why there's so many different tractors all lined up there. They've done some spot trials in terms of doing measurements there, so they can qualify that. So they do take this very, very seriously. Essentially, how the system operates then is there's a number of different components. If we start in the bottom left, there's an implement beacon. So this is just a magnetic Bluetooth beacon that we assign to each implement. That's attached to the implement itself. It just fits on the back somewhere out the way, and it just basically broadcasts its unique identifier. We have something similar that the operator can use on a keyring, so that there's a Bluetooth tag on the keys, and I generally encourage operators to put them in the lunchbox because they never forget the lunchbox. The keys they can forget, but lunchboxes are rarely missed. So as long as you've got it somewhere with something that the operator's always got with him, it will pick him up. And then we've got the telemetry module as well. And essentially that just plugs straight into the CAN bus on the tractor. It will pick the engine CAN bus up, as I said, the J1939 engine management, as well as then the isobus data as well that is floating around if it's an isobus implement. And it's really unique. So it uses the Bluetooth features within the telemetry module, scan which beacons are around it, and then it will automatically assign the driver and the implement to a job because it knows that those two systems are together working in parallel. It's got its own GPS system within it, so it has its own GPS and SIM card within there, so it is totally independent. But it is smart enough to recognise that if you're using it on a tractor that's already, for example, got isobus and RTK in that isobus system, it will use the tractor or the combine's positioning system. It will recognise it's more accurate than its own, and it will utilise the isobus RTK data if you're using that. So it really does give you that flexibility to have really precise positioning data rather than just a third-party sort of basic GPS. Essentially, it captures lots of different things. So it connects to, as I say, both the different CAN buses. It's got its own GPS antenna. The new system that was released in November has an external antenna, which we found is particularly beneficial for combine. It's got its own mobile data connection with a worldwide SIM card in it, so you can literally use it anywhere, and it will find the best network that it can. It has a 4 GB hard drive within the system, so it will store a lot of data in absence of having any phone signal, and it will upload that when it next finds the connection. And we've got the ability with the USB file transfer now. The only thing that's different in different installations are the cables that we need to plug into different things, and that then we just literally plug it into the diagnostic ports on your tractors or on your combines or your teleporters, and it will then just start working. There's different levels of subscription, so we can have just basic tracking. We can have more complex tracking that is rather than just position, it's position and fuel, and then we've got the position, fuel, and the sort of ultimate, which will be your yield data or your as applied data. And essentially what it's working on is the GPS positions. We've got the working times. We can then track the fuel consumptions, CO2 emissions, any of the torque, hitch or RPM settings on the machine. And it's interesting, we've got these things out with some machine manufacturers that are using it to support their machines better as well, making sure that they can see what's happening and that the machines are being looked after and serviced properly. You've got the ability within the system to set service schedules and make sure you can track all of that as well. When we put them on the combines, they can do yield and moisture as well, so we get all of that data and any of the isobus information that's floating around. And it's just sent autonomously to the servers over in Germany. So essentially, each tracker we putting a different. We have different plugs for each machines, so you can see there's a variety of different sockets and plugs on there that you can see, and we just plug them into the different things. We mount them then on the window where they've got good visibility and can broadcast signals, and that allows us then to automate all the data. And the system then just automatically tracks everything. So it gives you that ability to look at what your machine's done, the whole performance of that, how much time you've spent doing different things, and automate the collection of that data. So this is just an example of the different opportunities you've got then to track who's doing most work, what job's going on, how many hours different operators have worked. We can do the same for machines or implements. We can break it down however you want. The other good thing that's different about this system as well is that the data that we collect, you get all the raw data back. One of the things that I found when I've looked at data that's being collected on existing telemetry systems is that the data you get out of your back from the manufacturer is generally being filtered by the manufacturer, and it's a version of manufacturer's truth, not the actual raw data that was collected from the machine. So, for example, on my Lexion at home, I've already got the class telematics on there. I've put on this telematics system as well. I get a lot more data points from this system than I do out of the class one. And the data I get back from class, I had this argument with class last week that they're only giving me data for once every 5 seconds, even though they claim it was capture data every 2 seconds. I don't get to see that raw data. I only get a version of truth that class want me to see. And there is some editing of that raw data I can see that's going on. So that was something that I was totally unaware of when I took the manufacturer's own system. Here's just some case studies. So this is just an example of, this is a guy looking at as applied for herbicide applications. In this particular case on the sprayer, it's recorded all the operations, so you can see the flow rates, where the rates might have changed, whether intentionally or unintentionally. We do find that sometimes sprayers can be quite slow to respond, so we can look at the efficacy of over and under applying in different solutions. But in this case, what can we see? In this case, he's got the volume per hectare, the working height, the tank agitation pressure, wind direction, relative humidity, droplet size, all sorts of different things that can be captured that are on the isobus. They have linked it in Denmark with slurry spreading systems, and they've done some specific work on slurry spreaders with looking at weather stations that are actually on the spreader as well, to try and reduce greenhouse gas emissions. So they're actively adjusting the rates of acid that they're injecting into some of the slurry at variable rates, depending on the temperature and the wind direction, to try and reduce ammonia emissions of the slurry as they're applying that. So there's some quite innovative stuff going on, and they've done integrations into weigh bridges and weighing systems as well. So they're very flexible. This is an example of just yield mapping. So again, you don't need a monitor, you don't need a screen. With this system, you just plug it in. It's cheaper than a lot of the manufacturers one, and often these machines don't need unlocking. You can just plug it straight in, and it just streams the data straight to the server. We've done this recently, so I'm actually picking up yield data yesterday from down in New Zealand on a system that I'd installed down there back in December. So, for that guy, he hadn't got yield mapping. He thought the £4,000, the £5,000 that he was going to get charged to put on a machine, he thought this was a lot more cost effective to stick it on, and he can get the data. He can see it on his phone as he's driving up and down the field. I'm not sure what advantage we get from that, but we like to see where we are and what we're doing, even though we're in the cab. It's quite sad. I do that as well. You can track all your machines. This is just another example for contractors or people at machine share. If you wanted to know exactly on fuel use and where your fuel's gone, then you can split it up into different areas. You can, you know, we're contractors as well, and we can then, we've used the system over the last couple of years to put fuel surcharges where we've had different use cases where we wanted to charge more for fuel use because obviously what's happened with the fuel prices, it's gone up. So we've been able to evidence that and justify that with the farmers. It's given us some really neat records that we can present to that. It operates all over the world, not that that's that relevant. There's different integration with different systems happening. As with all these things, they're very open to who they want to work with and allow that data sharing. They believe it's your data and that you can put it where you want it. And they've got lots of different partners around the world that are supporting them. And that's it. If you've got any questions, then please ask along.
Thanks, Clive. That was really good. It gave a good overview of how the product works and how it fits into the farming system. I've just got one question: and this is maybe my own ignorance, but does the machine have to have Isobus, or can it work on machines that don't have Isobus?
No, so from the as applied data, it will only pick up the application data, I think, from Isobus machines. Amazon are a partner, so there could well be different links into the Amazon system that aren't necessarily Isobus. The team at Exatrec are really dynamic. We have made it work on other systems as well. So, for example, we've got an ag leader system on our sprayer, and when the guy was over, he literally just typed some bits into his computer, as these wonderful whiz kids do. Did a bit of can sniffing, identified, sat in the backfield, turning the rate on and off, turning different sections on and off. Within half an hour, he'd enabled it to do it. So we can make it work on other things if there's a use case for it. They're very flexible and want to make it work for customers. So as I say, it has two CAN bus channels it works on. So one is for the engine management. So a lot of tractors, a lot of modern engines, in fact, nearly all of them will have that engine management system on there that we can use for the fuel use. The Isobus is typically more than the second channel is then used more for the implement or combine data. So it's not just Isobus, but Isobus is the preferred.
Good. Okay. Another question for the folk watching is who owns the data, or what's the, and is it your data to use as you wish, or how does that
Absolutely,
work?
yeah. So the data, they've got an open API. So if you've got different software solutions that can pull the data down, you can work with your software provider, and they will happily work with them and provide that ability for them to be able to download and utilize the data in a system that you want to put it into. All the data is also exportable in ISO XML, in shape files, or in CSV format. So if you're a numbers whiz kid and like spreadsheets, you can download a massive comma delimited file if you understand all the Isobus DDIs, the digital something identifiers of each parameter on your sprayer. You can decode the whole lot, and it's got it all in there. So you could see which boom section was on and off on a sprayer, for example, where it was turned on and off. It's really in-depth data, and there's masses of it. I was staggered at how much additional data it was capturing that I wasn't capturing in other systems. As I say, that data is held on the German servers. It's all on a secure system. That said, I don't think Germany's in good light at the minute with the way its servers are, or the way it's protecting data. So I'll be careful what I say. I always had them in a bit higher regard than current political storms. But yeah, no, it's all there for the data. It's all there for the farmer, and you can, as I say, you can utilize it when you want.
Perfect. Another question: is it, do you lease the bits of kit, or do you purchase them, or how does
so they're all purchased? Yeah. So you buy them, you stick them on the machine, and you own them. And then there's an annual license that handles the data contracts and the amount of data that you're handling. So there's 3 different tiers. There's a basic one that will just cover the position. There's a more in-depth one that will do position, operator, implement, fuel, and then there's the ultimate one that does all the as applied and yield data and the whole lot. And they've got different pricing structures around them.
Perfect. Good. If there's any other questions, just pop them in the chat. But thank you very much for that, Clive. The plan for using Exatrec is to put it on a farm with a few pieces of kit, maybe on the main tractor and maybe on the sprayer or combine for this season, and try and track that fuel use and efficiency, and see what we can find out, and what efficiencies can be gained from going through that for this coming season. So we're looking forward to using that this summer. I've just got a couple of slides on the last piece of tech that we're looking at. So the final piece of tech that we're planning to look at is called a Stenon Farm Lab. It looks like this fancy spade on the right-hand side of the screen, and it's a in-field soil analysis machine. So at the bottom there is a sensor which, when it's put in the ground, will A, take a GPS measurement as to where you are, and then B, take an analysis and tell you what a number of parameters are as you're going through the field. So you'd walk a field in a W shape, or like you would normally taking a soil sample, or you could use it to look at good and poor parts of the field and try and track the crop during the season. So this is, I think it's German technology that we're looking at. We're just trying to get this one finalized for this season. And what it does, it looks at nutrients, especially nitrogen, phosphorus. It can look at soil organic matter, and can also look at soil organic carbon and magnesium, and also things like soil moisture and temperature and pH. And like I say, that is, as you're on the hoof walking through the field, you will be able to pick up on that. So the plan is to try and monitor a few crops using that on a farm through the season, just to see how the nutritional requirements of the crop change, and probably do a couple of split field trials just to try and see if by manipulating that we can increase, either reduce nitrogen or reduce fertilizer use, or increase yield. But we'll see how that one goes. And then this is just some of the advantages that is seen. This is taken for their website. So we will see how it goes. It's certainly interesting technology. It's something that the management group picked up on, that they wanted to look at trying to monitor crops on the hoof. We're using soil analysis a fair bit, but it is well, it's expensive, but it's also slow, as in it takes a while to get results back. Whereas something like this, where we can track nutrition of the crop or track nutrition in the soil, we will hopefully make an interesting project to look at and see how that refers back to what we would normally get from a lab. So we're just in discussions with Stenon about that at the moment, but the plan is that will be up and running for this summer as well. So as I said, we've got the three pieces of technology that we're looking at as part of this project. For the summer, we've got the Skippy Scout stuff, where we're looking at 3 fields, looking at spring barley, winter oats and winter wheat, and trying to use the information to inform our agronomic and nutritional plans for the season. We've got Exatrec, which is really going to look around the fuel use and trying to be more efficient with the inputs that we're using. And then again, looking at Stenon and how that's going to fit in with soil nutrition and maximising the crops that we've got. And like we've done for some of the other parts of this project, where we've done a kind of tech evaluation, this is one that was done for the livestock farm. Was looking at, I think it was the I think it was some of the Ritchie equipment, just trying to run through how easy it is for the farmer to use, what the reliability is like, what the benefits are, whether there's any drawbacks, how effective it is, what the value for money is, and just give an overall assessment as to why if we think it's beneficial or not. And this is really to try and inform the group, the other people, the other farmers in the northeast, to be able to give them a independent kind of informed assessment of it without having to invest in it themselves. So yeah, there's just a couple of things here, questions that's come through. So the idea with the Stenon is that we will try and validate some of the data that is coming through from it. So we'll look at the data that is in the Stenon, and then try and look at it. Well, we'll look at what the fields will be sampled previous to the crop going in, and then we'll try and look and see how accurate we think it is, or even if it's not, how accurate it is, if we are able to show differences and how that can feed through during the season. So that is the type of thing that we will be looking at as we progress through the season. Yeah, and that tech evaluation that we've got there is just the one that was for the combi clamp. So that's the kind of thing. Just an honest John's opinion of some of these tech and how it can work. Okay, is there any other questions? I think I've answered everything that has come up so far. I will stop sharing. If there's no other questions, the plan is that we will demonstrate this or we will trial this equipment through the season. We will either do an open day or we'll do another webinar later on in the year to kind of show our results, and then we can show it to the rest of the people in the group later on in the year. But if that's everything, I would just like to thank Clive and Edwin for coming along tonight and speaking about their products, and also to you guys for turning up and listening to us. If there's any queries about the project, then by all means get in touch with myself or Kirsten Williams regarding the project. There is lots of information on the website regarding the One Agritech project. So if you want to go on there, there's videos, newsletters, other bits and pieces. Or if you want to go on a mailing list, then by all means just email us, and we can go for there. So no. Okay, thank you everybody, and yeah, I wish you well, you're all at home anyway. I'd normally wish everybody a safe journey home, but everybody's at home. So just thank you very much for coming tonight, and stay in touch with the project as we go along. Thank you, folks.
Yeah, thank you very much.
Thanks, everyone.